everyone. Welcome to our Reef Rescue event. My name is Kiana, and I will be joining as your host from Cangeoeducation as we dive deep into coral reefs. With us today are two very special guests. We have Julia Baum, a scientist and coral reef expert, and Su Rynard, director of the Reef Rescue documentary. This event will consist of a virtual talk and presentation between our guests about their experiences and connections with the Earth's coral reefs, followed by a Q&A. If you are joining us from YouTube or Facebook, please feel free to type your questions directly into the chat. If you are joining us here on StreamYard, have your cameras and microphones ready for your turn to ask questions. We thank you so much for joining us, and we hope you enjoy this virtual talk. Without further ado, please welcome Julia Baum and Su Rynard.
Hello.
Hi, everyone.
Hi, Julia.
Hi, Sue. Great to see you.
I usually see you underwater swimming.
Yes, exactly.
Yeah. So I think the first thing we were going to do was just show the trailer. So I'll talk a little bit about that, and then we're going to watch a movie, right?
Yeah.
So Reef Rescue is a documentary film. It's about a group of scientists that live in different places all over the world, and they're working very, very hard, really working against time to help find ways that they can help save coral reefs and get them through this kind of climate crisis that we're having that's really affecting our oceans. So it's the full documentary. So what I'm going to show is just the trailer. So that's like a 3-minute introduction. But the full film you can watch on CBC Gem. If anybody has CBC Gem, which is it's free to stream on CBC Gem, part of the David Suzuki Nature of Things. And the other great thing is that Canadian Geographic has done this wonderful interactive website, and I think that link is going to come up in the chat box, and it kind of puts out the whole world, and you can go in deeper and deeper and learn more and more about reefs and how amazing corals are and some of the challenges that they're facing. So it's a really wonderful thing to do as well. Anyway, without further ado, I will share that film, which I think, video file. Okay.
Corals are tiny animals. The vast reefs they build support 1/4 of all marine life and are crucial to human survival. But now, these precious creatures are in crisis.
Disturbing news about the state of the world's largest living ecosystem.
Human activity has pushed atmospheric CO2 to its highest level in 800,000 years, causing catastrophic ocean heat waves that bleach corals of all color and life.
La Grande Barrière de Corail est en danger.
Scientists declared the 3rd ever global coral bleaching crisis.
It's very clear that 1/2 degree matters.
And with 1.5 degrees, 70 to 90% of coral reefs are lost. But at 2, it's virtually all of them.
The urgency of this cannot be overstated. The changes are real, the changes are rapid, and they can be quite extreme.
Let's face it, if conditions change fast, you have a couple of options. You move, you adapt, or you die.
They don't have thousands of years to adapt to these warming temperatures. They've got decades.
This is the story of scientists fighting a desperate race against time, unlocking the secrets of millions of years of coral evolution and trying to speed it up.
Some corals are doing better than others, and the question is why? Can we help them? Can we accelerate natural selection? Can we accelerate adaptive rates?
If we are going to save coral reefs, it means that we have to start intervening.
These ideas are new and experimental.
Have we ever approached our science that way? No.
Si on fait rien, dans 50 ou 100 ans, on n'aura peut-être quasi plus de coraux.
And for the first time, this daring research will be put to the test.
Honestly, we don't know whether it's going to work.
But what is the risk of doing nothing at this point? The risk of doing nothing is the risk of risking every reef on the planet.
Wow. You made such a beautiful documentary, Sue, and it's so powerful, and it was such a honor to be part of it. And it's just, I know I've seen that trailer so many times, I've seen the movie many times, and it just like always chokes me up because I think it's such a personal story for me, and I'm sure it became very personal for you and working on it for so long. So I really hope that everyone watching today gets a chance to actually see the entire movie. It's really, really powerful filmmaking. And it's been shown to audiences across Canada now, and also across the United States and in France. It's won awards. It won the Best Conservation Film at the 2020 Jackson Wild Media Awards. And I'm in awe of you. I think it's such an amazing film, and that venue of storytelling via film is such a powerful way of getting the message across about the need to conserve coral reefs. So I wanted to ask you what it was like for you making this film as its director.
Yeah. Well, I guess the first thing just about directing and making documentaries in general is it's always a privilege and really exciting to enter someone else's world, because I'm a filmmaker. I'm not a coral reef scientist. So I kind of get to enter your world and the other scientists in the film, and I see something that, you know, personally is I just feel very privileged to have experienced this part of your life, and to see the work in action, and to get close to the people who are really working hard on these things. And so anyway, so that's the amazing part. It is wonderful. The hard part, of course, is the subject matter and the challenge of putting that into a film where you want to, you really want to capture what's really happening. At the same time, you don't want to scare people. You want to put it in context, finding both, the awe and the wonder, but also really find the problem, articulate the problem. But I think the best thing for me is always that the scientists in the film, in these films anyway, are people who are working for change. And I think it's so easy to get overwhelmed with all the challenges that we have. We've just been in a global pandemic. We have a climate crisis. These are all really hard things to deal with emotionally, and emotionally for the people close to them, emotionally for viewers. So I think that if people especially the people in the film and who we're telling the story about are those on the front lines who are actively engaged in finding solutions, I think that's very empowering, and I think it's very positive. And I think it's a great way to tell an environmental story, because if you let yourself get overwhelmed, you just get paralyzed. But if you just say, what can I do? I'm going to be part of the solution in some small way. Whatever my little contribution is, I want to do that. It's a way to really, it's just a way to get through these really hard times we're in.
I love that. I think that's such a great answer, focusing on the solutions and focusing on the fact that we all have a little role to play. There's something that all of us can do. And I think the role that you're playing is so important, right? You bringing our story, the scientist story, to this like mass audiences, which is amazing. Is that what made you want to become a documentary filmmaker, or what got you into this in the first place? And for the students watching today, how does one go about becoming a documentary filmmaker?
Well, there's certainly no one answer to that.
I'm sure.
Everybody has their own path. And I came to documentary late in that I started, I went to actually art school, and then I was doing film and video and media art. And then I was making short films and drama. But in the last while, I've really felt strongly about what's going on in the world. And I felt that the documentary was the best place. So I brought lots of experience to it, a lot of creativity from other places. But there's so many different paths these days. I mean, you can start by picking up your own camera and make a film. That's like the easiest, not even easy. But that's one entry point. So my journey was that one. But yeah, there's lots of different ways. And I think it is a kind of creative career, and you do have to kind of find what works for you.
Mm-hmm. Great. I'm sure that's inspiring lots of kids out there.
Yeah. And you, Julia, too. So you have a totally interesting career and as a marine biologist, which is very cool. And I'm just wondering how did you start too? How did you get involved in your work?
Yeah, well, I know that a lot of people who become marine biologists, grew up by the ocean and have that early childhood connection. And I think, of course, for all of us, it starts with a connection, but I actually didn't get that connection until pretty late in life. I grew up in Southern Ontario. I'm from Guelph. And so I didn't see the ocean until I was 10 years old on a family holiday out to the maritime provinces. Saw the ocean then. Still wasn't really that hooked, to be honest. And for me, it happened during my undergraduate degree at McGill University. I had this amazing, inspirational teacher who just opened up this whole world to me of the ocean, and also started showing us how impacted the ocean is. And so I'm going to show a few images here, if I can. So this is the coral reef that I have worked on for over a decade now. And this is where Sue came to film with me and my crew. It's right in the middle of the Pacific Ocean, just above the equator. It's called Christmas Island. And this is one of the island's many, many stunning coral reefs. And, I worked for a long time in other ocean ecosystems and then started working on coral reefs. And they are, I think, the most amazing ocean ecosystems that there are. And the documentary trailer already pointed out to a few of those things. And so one of the things is that coral reefs hold or support over a quarter of all marine life. And that's like really, really mind-blowing, because coral reefs are pretty tiny. Like the Great Barrier Reef is big, but there are lots of reefs that are tiny. And if we smushed all of the reefs in the entire world together, they would still only cover 1% of the entire ocean's surface. But they have way more marine life packed into it than they should. So they have like this disproportionate amount of marine life. And that means if you're diving on a healthy reef, you can see hundreds and hundreds of fish species and hundreds of coral species and invertebrates all in this one location. And just the colors and shapes and sizes and behaviors that you can watch are just absolutely mind-blowing. And then, so that, of course, was part of the attraction, right? They're just really cool ecosystems. And then we also know that they're being impacted by lots of different things. So a lot of reefs get overfished, and we pollute a lot of reefs because sewage and different agricultural inputs go into it. We also develop a lot of reefs. That's where people like to clear the land and put coastal resorts that we go on vacation to. There are diseases and big coastal storms, and then the big huge problem that is sort of superimposed on all of these other problems is climate change. And that is, of course, the subject of Reef Rescue. So to me, I think it was this joint thing of falling in love with these ecosystems and then realizing how impacted they are and wanting to do something to try to save them.
You know what, Julia, I have one little question. And this was something that was amazing to me starting out too, was constantly realizing that the coral, we talk about coral, that it's alive, but it's not a plant. It's not a rock. Like a coral is what? Tell us what a coral is.
Yeah, I think it's easy for people to think that a coral is a rock because it's just this hard, stony thing sitting on the bottom of the reef. But it's actually an animal. They're very distantly related to jellyfish. And so what I'm going to show you here, or what I hope you can see on the screen, is this zooming in close-up of a coral. And so this is what a whole coral colony looks like. On a reef, there's hundreds and thousands of colonies. So we've just zoomed in this upper photo to a single colony. But then if we zoom in even more, so we just zoom into this little part, this is what it looks like. And what each of these little circular things that you see is an individual coral animal. So the colony is made up of hundreds or thousands of these little animals. And if we zoom in on one of these little polyps, this is what it looks like from the top. So this is its mouth. And this is another view. So this is a view from the side. So the mouth is in the top here. And each polyp has these tentacles. They generally are retracted and hidden inside during the day. And at night, when we're usually not diving, so we usually don't get to see this, but at night, those tentacles here come up and they're waving them about in the water and basically trying to trap plankton, very tiny microscopic food that's floating in the water. So they're actually animals, but that, as you can imagine, doing this and just trying to trap food from the water like this is maybe not a really efficient mode of hunting. And that it's true, it's not. So that's actually not how corals get most of their energy. So they get most of their energy from tiny, tiny little microscopic algae that live inside them. And these are called, they have a long, complicated name, Symbiodinium. And they live in a really close relationship with the corals. So these tiny microscopic algae actually live inside each of those little coral polyps, and they photosynthesize the same way that plants photosynthesize. And so when they do that, they're basically taking energy from the sun, converting it into food, and they're sharing that with the corals. And that's how corals actually get most of their energy. And when corals bleach, that's when there's a bleaching event. So when water temperatures get too hot, kind of uncomfortably hot for corals, what's actually happening is they're kicking out their little partners. They're kicking out their symbiotic algae. And so that's when corals look white. They're not actually dead at that point, but they are sick. And that's a real warning sign to us that they're in trouble because of warming waters.
Yeah, that's amazing. It's still amazing to me when you're doing this with your hands, but it is, we do have some shots in the film where you actually can see that. And it is kind of still incredible to me to think that this is a little animal, because we really don't, and that it's so unique. It's pretty fantastic. So
yeah, absolutely.
Yeah. And I think the other thing that you mentioned that is a challenging thing is the climate aspect of all this. Climate change, the climate crisis, all these words we hear all the time that are difficult, that we often turn away from because you don't want to think about it that day. But tell me a little bit about what your experience on where you work, which is, I know you work in Victoria, but you also work far in the Pacific Ocean in the Christmas Island. So tell me a little bit about what that experience was.
Yeah, well, so I'm just going to show you a photo of these two corals here, because in the trailer for Reef Rescue, one of the scientists mentioned that not all corals are affected equally. And that's true. And this is a great photo to show that. So what you're seeing in this photo is, well, a bunch of different corals, but hopefully in the middle, you can see these two coral colonies, and they're actually the same species. So they're both a particular type of branching coral, and they've both been exposed to warming water, but this one here on the left has completely bleached, and this one here on the right hasn't. And this sort of exemplifies this mystery that a lot of the coral reef science community is trying to figure out, which is, why are some corals tolerant of heat stress and why are some really vulnerable? And the idea is that if we can figure out what makes corals like this one on the right tolerant of heat stress, then maybe we can basically engineer reefs to make them more tolerant to climate change. So that's one of the ideas. What we saw on Christmas Island, I showed you that photo before of the beautiful reef, and that's how a lot of the island looked before a big marine heat wave. So about 6 years ago, there was a huge marine heat wave, this event that went all around the world. It caused mass bleaching on the Great Barrier Reef and some mortality. And it hit Christmas Island, where I work, really hard. And a lot of the coral died in that event. So Unfortunately, Sue only, you only were able to come out to Christmas Island after that happened. And so the reef that we filmed for the documentary was that aftermath of that huge marine heat wave. So if students get a chance to see that, they'll see what that reef looked like afterwards.
Yeah, so I'm going to play a scene from the film. It's about 4 minutes long. And it's a scene where you're introduced to the place, this wonderful place where, since it's the middle of winter now, you probably all wish that you were. But after that, it introduces Julia and her work, her team, how they dive. Like, not everybody goes to work on a boat, but Julia does. How they dive, and then that amazing underwater world. And the challenge of this that Julia encounters in this particular scene is the change that happened to that amazing underwater world. So we show a little bit of just that transformation from healthy to sick, and how the ocean, you see actually how the ocean's been affected, and also how the researchers like Julia are affected, because this is, this is very, something that's very close to people's hearts. It's what they invest their life's energy in. And to see these reefs and the animals all struggle like that is heart-wrenching. So anyway, here we go.
It is the largest island made entirely of coral in the world. Julia Baum is a Canadian marine biologist. For more than a decade, she's been coming here to study the reef's unique ecosystem.
It always feels great to be back. It's a bit of a mix of emotions. There's so much invested in every single trip. Always a little bit of excitement about an adventure that's about to begin, and also maybe a little apprehension just to make sure, is everything going to go okay? Hey. I think that it's actually, I know it sounds crazy, but I think it's actually, you're gonna drop there.
It's Julia's first day out on the reef this year. The team will dive down to take stock of the coral.
When I first started doing research on the ocean, I had been so focused on sharks and fish, and at some point I think I kind of looked down and saw the coral and realized, hey, the coral are the whole foundation of this ecosystem. And if we're worried about this ecosystem, we really have to be worried about the coral themselves. We have hundreds of corals tagged all around the island, and we take tiny tissue samples from them. We can take the photos to identify individual coral colonies themselves and get a sense of who's there in the community. A brain coral is one of the main types of corals that we've been working with. There's also branching corals and flat corals, so lots of different shapes, and those are important because they provide different types of habitat for fishes.
Each year, Julia and her team meticulously tag, sample, and photograph the same 40 plots of coral, building a timeline of how the reefs are changing. In 2014, this is what Julia's camera recorded. 2 years later, this is what she discovered. The water temperature had risen by 4.5 degrees Fahrenheit.
The heat set itself down on this island and just got a chokehold on it, and it just kept going and going for 10 straight months. And what we saw was a complete ecological meltdown. By the time we came back in March 2016, almost everything was dead. It was like a graveyard. It's just hard to believe that a whole island can die in less than a year.
How'd it go?
Okay, tough. A lot of stuff going on there.
I want to look at both of those dive slates and compare the corals. Photo for all of them, tissue for all of them, and growth for some of them.
Yeah.
Okay. It's pretty devastating being down there because I just remember that being my favorite site. And then it just feels like, how did this happen? And even though obviously intellectually I know exactly what happened, but emotionally it still feels like it's just really it's a pretty sad remnant of what it was. It's gone, really.
Wow. It's not easy for you to watch that again, I guess, Julia.
Sorry, Julia, I think your mic is on mute.
Oh, sorry about that. Yeah, I just wanted to say that that's it's still kind of, hits in the gut watching that. It's still a hard watch. So I want to point out to people that not all reefs have undergone this mass mortality. Christmas Island, where I work, just happened to be the hardest hit out of anywhere on the planet in this big heat wave that happened in 2015 and 2016. So there still are beautiful reefs in the world, and that's what I think we really have to focus on saving. And just to take people to Christmas and show them what it did look like and some of the beauty there. I just want to show a few more slides of the island. So this is kind of taking people to the island in a different way than you did in the film, just through pictures, but hopefully it also gives some sense of what it's like. So this is a really low-lying island, very, very flat. There's no mountains, no hills. It's very, very close to sea level. And this is what it looks like when we're flying in. And the island is home to some of the Pacific Ocean's most important and largest seabird colonies. So we're always underwater studying the corals and the fish, but there's also a whole amazing seabird life on top. And then this is the reef that I showed you at the beginning, one of our favorite sites. I'm just going to show you some of the really cool underwater life that we see. So I don't know if you can tell what this is, but this is an octopus. And this is how you often see them, very, very camouflaged and just sitting very still, so hoping that you don't notice them. But the color transformations that they can undergo underwater are just extraordinary. We regularly see sea turtles and reef sharks. Sometimes you're so focused doing work, us scientists will have our head way down in the coral, focus on doing something, and then you'll come up from the dive and your dive buddy will say, oh yeah, there was a reef shark just, kind of circling around you the whole time. And they're not dangerous, but it's just kind of funny how we can get so focused on things that we don't, we're not seeing everything else around us. There are quite a few manta rays on the island as well, which is amazing. And we love seeing manta rays. And dolphins as well, quite a few different types of dolphins. And we see them pretty regularly, especially from the boat. They like to swim alongside the boat. And so that's always just an amazing experience. And then this is the little boat that we work on. It's so small that Sue, when you were out filming your crew, we had to, charter another boat for your team because our boat is so tiny. But this is the little boat that we work on. And you just saw the back, and that's the front. So we have it just, jam-packed with gear, with all sorts of dive tanks and coolers and all sorts of equipment. And we're diving, and then we often are bringing samples up from underwater, and sometimes we have to process those samples right on the boat. So there's often some science going on in between the dives as well. So it's busy days, as I know you saw when you were out there with us. This is me taking some images, capturing images of the bottom of the coral reef, and we do that with this big white thing with fluorescent lines on it that you see. We call a photo quadrat. So this is sort of a coral reef ecologist, like tools of the trade, very basic material that we buy at Home Depot. And the reason that we do this is just so that you have a sense of scale in the photos. So we can take photos and then afterwards you can tell how big they were because we've got that all, the size of that all marked out. This is another member of my team doing fish surveys. So remember I said there are hundreds of species of fish, and we have a team that swims along a certain line at a constant depth underwater, and they count every single fish that they see and write down what species it was and what size it was, which is just amazing. Takes an amazing amount of skill to do that. This is how many fish there can sometimes be in a single viewpoint. So you can imagine trying to get a handle on how many that is. And this is just some of our other work, one of our permanent plots. So you can see in the corners two stakes there that we've got driven into the reef just to demarcate one of our permanent plots. And then this is back in our lab. We don't actually have a there's no research station on the island where we work. So we set up these makeshift labs, which are also in the rooms that we're sleeping in. So we have all this equipment spread out, and then at night we kind of tuck it all back in its place and go to sleep. And so it's our hotel room is also our makeshift laboratory while we're there. And then we also love to spend time with the kids on the island, and we spend a bit of time working with them on every trip that we go out there. You know, talking to them about the coral reef. This was an activity we did where we were teaching them how the food web on the coral reef works, how all of the different species are interconnected. And that's always a really special part of what we get to do on the island. So you were talking before, Sue, about working with scientists and you know, in the course of working on the documentary that you're working with scientists who are trying to save coral reefs. And I'm wondering, you know, what gives you hope really about trying to save coral reefs in the face of this climate crisis?
I think, I think that there are many people working on different solutions, and part of the thrust of certainly the Reef Rescue film were some really, really interesting ideas about how corals can't adapt quickly enough. And I think that's happening in not just corals, but all kinds of creatures, that the way we're changing the environment, nature is usually very resilient, but it can't keep up with the change. So I think that scientists are really tuned into what the problems are. And like this idea of, you know, with corals, which was to really understand the possibility of speeding up change and assisting their evolution to make sure they can survive into the future, was super, super inspiring. That's like an amazing idea. And the idea that these ideas are even happening, like that people aren't just going, you know,
yeah,
this is awful. It's like, okay, why did this happen? And taking responsibility for the way we live. And as your slides at the beginning showed, all the way we're changing the earth and why that's causing grief for so many creatures, and then trying to solve the problem. Because I think, and I mentioned this at the beginning, if you can, you know, if these things are overwhelming, and a way not to be overwhelmed is just to find your piece of the puzzle and do what you can to help change the situation. And I mean, that's what gives me hope, really, because it's daunting. And I think you just have to every day feel like you're working on the right path, and that helps a lot.
Yeah, I agree with you completely. You know, I think that's so true. Just exactly how you said it, that climate change can feel so overwhelming, and sometimes we don't know, you know, what we can do about it. And so the film really shows the exact way that coral reef scientists are trying to go about saving it. But I think that sometimes, you know, those of us in Canada think like, we're so far away from coral reefs, what can we possibly do to save coral reefs? And something that I've been thinking about a lot is that, you know, we have to solve climate change in order to save coral reefs. And so in Canada, we actually have a really important role to play there, because we're some of the biggest greenhouse gas emitters per capita. So per person, on a per person basis, we have some of the highest emissions. And so one of the things that we can really think about at home here in Canada is how can we, individually and in our families and schools, start to try to reduce greenhouse gas emissions, because every bit that we are able to do that will help save coral reefs. And so I just wanted to show people a few resources. I'm going to file through them, but then they're all up on my website, and I'll show you that at the end as well. So there's lots of different books that have come out recently. And I guess what I'm getting at here is that I think one of the best ways to really save coral reefs is to learn more and understand more about climate change, and understand more about how important it is for us to reduce greenhouse gas emissions. And so I'm just going to show you a few resources here. I think this is an amazing book by Katharine Hayhoe, who is another Canadian climate scientist. It just came out, called Saving Us, and it's a really positive look at what we can do. There's an amazing website called Drawdown, where they have done the research to show the top 100 solutions for climate change. And if you don't like reading, or you don't want to, do that, there's also great podcasts out there. And these podcasts each tell a really interesting story about climate change and solutions. And so this is one that I love, called A Matter of Degrees, with Leah Stokes and Catherine Wilkinson. And this is one called How to Save a Planet, which I really love it because it's so solutions focused. And I actually did an interview with them a couple of weeks ago, so my episode will be up soon, but I loved this podcast before I was on it. I think it's a really cool and positive way of showing the solutions that we need. And then there are a couple of TED Talks that I really like. One, again, is by Catherine Wilkinson, and another by Katharine Hayhoe. So all of these are up on my website. My website is simply juliabaum.org. And if you go there and go to the Take Action tab up here, you'll come to the Change button, where you can learn more, and everything I just showed is up there. So I think there's good resources there, and there's so much information out there that comes in all sorts of different forms for people to learn more about how they can get involved to make positive change.
Thanks, Julia. I think there was a couple tips in there for me too. I thought I had it all down, but it's like I dropped it. That's great. That's great. And I wanted to just pick up, I know we're going to go to the questions next, but just pick up on one thing you said. And I think you used the word connected at one point, or connectivity. And I think that's the thing that we forget. Like, you think, oh, I'm in Toronto, I'm on the Great Lakes, I'm not anywhere near an ocean, but everything in the planet is connected. And every action you do here reverberates through a chain of events all the way around the globe. And we have to kind of think more about the planet rather than just, our little life that we live in, because our impacts matter. And we are all connected. We're connected through the impact we have, but also through the web of life, which is that's a whole other lunchtime talk. But everything is linked, and from the water to the air to the life forms. And
yeah, absolutely.
We can't take ourselves outside of that, right?
Yeah, I think you're absolutely right. Well, I know you're absolutely right. And I think that sometimes people, then they start to feel like this guilt of like, oh, it's my impact that's doing that. I think these are global problems, but the way that maybe we can think about it in a positive light is that everything is connected. And so if we start making positive changes, it's going to reverberate and have a positive impact.
Mm-hmm. Yes. Yay. Thank you.
Wow. Amazing. What a wealth of information from our incredible guests. Thank you so much, Julia and Sue, for your wonderful presentation and talk. A little virtual applause.
Thank you.
Thank you.
Now that you've learned about Julia's amazing work with coral reefs and her collaboration with Sue on her remarkable documentary, Reef Rescue, it is now time for some questions. So for this part of our event, we will give classrooms about 10 minutes each to ask a few questions, followed by questions from our viewers on Facebook and YouTube. So we have the Danforth class. Please have your microphone and camera ready. You're on for Q&A.
Woohoo.
Microphone and camera ready. You're on for Q&A.
All right. One of the first questions a lot of my students were curious about was whether or not what would happen. One of the first questions a lot of my students were curious about. Lag time. Was what will happen when the coral reef actually, if it were to disappear, what would happen? Sorry for the lag time.
That's okay. Maybe I'll just can you put it on mute while I'm answering, and then we won't get the feedback? That's okay. Yeah, so the question was, if the coral reef dies, what happens? And so, yeah, that's a great question. So, well, first of all, even on Christmas Island, we saw 90% mortality. So almost the entire reef died. But at the same time, in the years after that, we saw lots of little baby corals coming back. And so there were still some alive, and there were still some that started reseeding the coral. We started seeing all these little tiny babies, and then bigger juveniles about this big, of a bunch of different species all over the reef. And so it's really important to know that coral reefs can recover. They have the capacity to recover, but that under climate change, we do need to work really hard to limit how much warming there is on the planet. Because if we keep warming and warming and warming, then big heat waves will keep hitting them, and they'll hit them before they get a chance to recover. And that's what we want to avoid. But given a chance, they have a really remarkable capacity to recover.
That's awesome to hear. The other question a lot of my students had was for both Sue and Julia. During your time together, what was your favorite memory of your time on the coral reef?
Oh, I'd love to hear Sue's.
Oh, yeah, that's a hard one. That's a hard one. I think it was just, well, first of all, it looks amazing and beautiful, but the workday starts with, it's a sunrise and ends basically with sunset. So something to and these guys don't even end at sunset. At sunset, they go inside their little rooms where they have their makeshift laboratory and continue working. So there was a lot of hard work done. But I guess for me, the favorite thing was just the way that we were able to see a reef and have, let's say, like a special guided tour, because everybody there, like Julia, were so informed and so interesting, that it was like, yeah, it was like the best guided tour in the universe, because I learned so much and I saw so many things that I wouldn't have known on my own. And it was wonderful to discover all that.
Yeah, and I think for me, it's a very funny experience being a scientist, and just you're used to going about your work, and then suddenly to have a camera crew in your face is just a really funny experience. And I think, Sue is so wonderful about that, but we're not actors or actresses, and it's just a very funny experience. So it's we would often have to do scenes in different places, and Sue might say, just talk amongst yourselves about what you're doing, and we would kind of look at each other and feel so awkward, because we feel like, okay, what would we normally be saying? And I don't know, it's just a very funny experience that probably a lot of scientists don't get. And I think what we all say to ourselves is, oh my God, we're such bad actors. So not that documentary is really acting, but you're just not used to talking when there's a camera on you. So that's a little bit of a funny feeling.
Yeah, for sure. But I think the end result is very compelling. So, and their editing is always your friend.
Yeah, right. Sure. Well, we were in your good hands. Oh, you're on mute now.
That's fabulous. Thank you so much for sharing. And another question we were curious about was, where can we watch Reef Rescue? We've been searching around trying to find a copy. Thank you so much for sharing. And another question please and thank you. Curious about was,
you should be able to find it on CBC Gem, which is on Gem. It's part of the David Suzuki Nature of Things series. So look under the Nature of Things and then look for Reef Rescue.
Yeah, we can also try to find the link and send it to you.
Yeah.
All right. Thank you so much for your questions. Next, is there one more?
Another question a lot of my students wanted to know was...
Thank you so much for your questions.
Thanks.
Next,
another question a lot of my students wanted to know was... Another question a lot of my students wanted to know was...
would you like to ask that final question? You can go ahead. All right, on to our next classroom from Heartwood Learning Community for a few questions.
My question is what are you going to do about it? Like, how are you going to save the coral? What's the process of saving it?
Great question, complicated question. So I think you'll get a really good idea of that if you watch the whole movie. And so I think there's two things that we can focus on. And so the first is focusing on working on the corals themselves. And that's really what Reef Rescue is about. It's about scientists all around the world working on the corals. And what they're doing when they're working on the corals is trying to figure out which corals naturally can withstand heat stress, so naturally can tolerate being in hotter waters than normal. And then trying to figure out, is there a genetic component to that? So is there something, trying to figure out exactly why they're able to tolerate hot water, and basically if that's because of the type of symbiotic partners they have, or it's a result of a certain type of gene that they have. The idea is that we might be able to manipulate the genes or manipulate the symbionts in other corals and then plant those corals out on reefs so that when they get hit with marine heat waves, they can survive. So that's one way, and that's the way that most coral reef biologists are working on right now. But the other way that I was talking about a little bit a minute ago was the fact that in addition to doing that, we also need to be working on preventing the planet from warming up much more, which is really more getting at the root of the problem, which is all of our greenhouse gas emissions, right? And so I, as a coral biologist, I've worked on the coral side, but over the past couple of years, and especially during COVID, because I'm in Canada, I've been focusing a lot more on thinking about how can we in Canada directly limit our greenhouse gas emissions? So how can we actually solve climate change? And I think that there's tons of things that we can do in Canada. And so the exciting thing about that to me is that it's not just a few coral biologists around the world trying to solve the problem. It's like all of us have a role to play. And so that's things like thinking about how much energy we use. And so things like thinking about, are we driving great big huge cars? Could we drive a smaller car? Could we drive an electric vehicle? Could we take a bus? Could we bike? Could we walk? Things like that. How much energy do we use if we go on vacations where we have to fly around the planet? So airplane flights cause a lot of greenhouse gas emissions. So there's a lot of things that we do in terms of how we use energy to transport ourselves places, to heat our buildings, to heat our schools, to heat all of the buildings that we're in. That all of that energy use causes emissions that are heating up the planet. And so what we really need to do in Canada is think about transforming the way that we use energy. And so in fact, a lot of people are working on things like renewable energy, things like solar power and wind power and wave power. And so now in my mind, when I think about saving coral reefs, I also think about all of those people working on those things to develop new technologies that mean we'll be able to use energy in safer, more efficient ways that don't cause greenhouse gas emissions, and then all of the things that we can do personally to try to reduce our energy use.
Do we have another question from Heartwood Learning Community?
No, we don't have. We have no more questions, but thank you.
Okay.
Great. Thank you so much. Okay, so we will turn our questions over to, there we go, from YouTube. What is your favorite thing about your job?
That's for Julia.
Well, I don't know. I think your job's super cool, Sue. So I don't know who it's for. But as a scientist, my favorite thing about doing science is making a brand new discovery. So having an idea, like, I want to figure this thing out, and knowing that nobody else in the world knows what the answer is to it. And then you do the study, and at some point you realize what the answer is. And you have this moment of just amazement where for a second you realize, I'm the only person who knows this. Like, I've discovered something that is brand new. Of course, then you're going to share it with the world. But that just moment of discovery is never gets old. It's really, really exciting. And then the other things that I love about my job are teaching and training students and getting to talk to students and excite people about science and coral reefs.
Amazing. Next question we have from Bella Sales. Is it dangerous exploring coral reefs?
Great question. So I guess it depends how deep you're diving. So we do all of our work underwater on scuba. And so there's always some risk inherent with that. It takes training, first of all, to become a scuba diver, and then second of all, to become a scientific diver. We dive pretty shallow on the reef, so we're only in about 10 meters of water. And so we're never really that far from the surface. So we have a lot of training, we take a lot of precautions, and so we've never had any problems, knock on wood, but safety is something that we take really, really seriously.
All right, next question from Catherine Tang. How long will it take to make corals healthy? And what does it take to become a marine biologist?
Right, great question. So how long will it take to make corals healthy? Well, after a big heat wave, like the event that happened on Christmas Island, it can take about 10 or 20 years for the entire reef to recover. So that's an individual reef. If we're thinking about all of the reefs on the planet, I think that's what we're going to find out this century, really depending on how much we're able to limit warming. And the hope is that if we can limit planetary warming to just, not much above 1.5 degrees Celsius, that by the end of this century, so by the time you guys are old men and women and maybe your grandchildren, that we will have healthy coral reefs around the world. That's the plan. What does it take to become a marine biologist? Well, we're going to need more marine biologists to help make that happen. So it takes training. So science courses, biology courses, and other science courses at the high school level, and then at the undergraduate level, so the first degree at university as well, focusing on biology.
Okay, our next question is from Brittany Melnick. Tack on to the favorite part of your job question. Students are curious if you have a part of your job that you may not enjoy as much. So I would also like to hand over this question to Sue as well to answer what the favorite part of your job is, and then to answer that following question.
Well, I guess for me, the least favorite part is, the fun part is when you're actually filming and making the documentary, but there's a lot of work. I'm sure Julia has her version too. That's more raising money, planning, writing, the grind. There's a lot of, it's not just every day you're out there, you have to make it happen. And to make it happen, there's a lot of work that goes on in the background before things happen. So that part is less fun, but the reward is worth it.
That would be my answer as well, the exact same thing. There's a lot of work that goes on behind the scenes, and just takes a lot of perseverance to make those amazing days out on the water happen.
Mm-hmm.
Next question from Carmen Marble Beck. For actually Kaya, age 11. They ask, what animals that help the reef are in danger? If so, how can those animals be helped?
Right. So it really is the corals themselves. So the corals that are most in danger and the corals that most scientists are focusing on trying to help. And then beyond the coral animals themselves, there's lots of different fish on the reef. And some of the most important fishes on coral reefs are herbivores. So they eat plants on the reef. There's lots of different types of little algae that live on the reef. And if those algae get out of control, they can overgrow the coral. So herbivores, so beautiful fish like parrotfish, which you may have seen photos of, they chomp down the algae and they kind of keep that competition between the coral and algae in check. So they're also important, and we can help them by limiting the amount that they are fished. So just preventing overfishing of those species.
Okay, we've got a question from a grade 5-6 class. What other areas besides Christmas Island do you research?
Well, I would love to research other coral reefs in the Pacific, but this might be a surprising answer or not. But during COVID, we haven't been able to travel internationally. And so for the past couple of years, we started doing research here in Canada. And so we are in Victoria on Vancouver Island, and we have started researching kelp forests around the coast of Vancouver Island. These are lush underwater forests, they're called. And they're really important ecosystems here on the coast of BC. They're also pretty vulnerable to climate change. And so we've been researching them for the past couple of years.
That's amazing. I think that concludes our question and answer period. Thank you so much to all our viewers who contributed their questions, and of course to Julia and Sue. We have reached the end of the hour for our event. Sue and Julia, you are both such an inspiration, and we are so grateful to have had this opportunity to learn about your work. To all of our classroom viewers, thank you so much for your participation. It has been so fun to see you. If you wish to learn more about the documentary and coral reefs in general, please check out our resources on our website, cangeoeducation.ca. Once again, thank you everyone, and have a lovely rest of your day. Goodbye.
Nice to meet you.
Thanks, Anna. Thanks, everyone.
Yeah, cheers.